Assalamu alaikum guys, my name is Sarfaraz Narejo and I'm studying in Mehran University of Engineering Technology JAMSHORO in Department of Metallurgy and Materials Engineering, bearing the roll number 19MT33. I'm currently studying in second year and third semester. Today the topic of my presentation is Maxwell's relationships in thermodynamics. I'm going to discuss the following topics in my presentation. Number one is importance and requirement of Maxwell's relationships, and number two is four Maxwell's equations and their derivations in thermodynamics. Firstly, I will discuss the first point, which is importance and requirements of Maxwell's relationships. The Maxwell's relationships establish the relation between various thermodynamic quantities like pressure, volume, entropy, enthalpy, temperature, internal energy, Gibbs free energy, and Helmholtz free energy, etc. When we need to measure change in temperature with respect to change in volume having entropy constant, in which we are interested, which are not easily measurable, then we move to utilize Maxwell's relations. For example, if we are required to analyze the change in thermodynamic quantity or quantities with respect to other quantity at a constant, change in temperature with respect to change in volume having entropy constant. As far as it is concerning of not availability of equipments that are required to be used in analysis process, for this we use Maxwell equations to determine the change. Following are the four Maxwell's equations and their derivations in thermodynamics that will be discussed ahead. First, Maxwell's relation from internal energy change in temperature with respect to change in volume having entropy constant is equals to minus change in pressure with respect to change in entropy having volume constant. According to first law of thermodynamics, dou Q is equals to dou U plus P dou V. That makes equation number A. According to second law of thermodynamics, dou S is equals to dou Q upon T. Dou S into T is equals to dou Q. We can also write it as dou Q is equals to dou T temperature T dou S. Now we will put the dou Q value in equation number A. Then T dou S is equals to dou U plus P dou V. Now T dou S minus P dou V is equals to dou U, or it can also be written as dou U is equals to T dou S minus P dou V. It makes equation number B. As we know from differential equations that dz is equals to m dou x plus n dou y, it makes equation number C. And similarly, dou m upon dou y having x constant is equals to dou n upon dou x having y constant. Observed from equation B, then m is equals to t and n is equals to p. Then from equation B, dou t upon dou v having s constant is equals to minus dou p upon dou s having volume constant. Here it is derived first Maxwell relation. Moving forward, the second Maxwell's relation. Here we have from H delta T upon delta P having S constant is equals to delta V upon delta S having pressure constant. Let it derive. We know that enthalpy is equals to U plus PV makes equation A. By partial differential equation A with respect to U, dou H upon dou U is equals to dou U upon dou U plus V dou P upon dou U plus P dou V upon dou U. By evaluating, we get dou H upon dou U is equals to 1 plus V dou P upon dou U plus P dou V upon dou U. This makes equation B. By multiplying both sides of equation B by dou U, we get dou H upon dou U into dou U is equals to dou U plus V dou P plus P dou V. It makes equation number C. Dou H is equals to dou U plus V dou P plus P dou V. We know that dou U plus P dou V is equals to dou Q is equals to T dou S. Dou U is equals to T dou S minus P dou V. Putting the value dou U, dou H is equals to T dawa S minus P dawa V plus V dawa P plus P dawa V. By evaluating, we get dawa H is equals to T dawa S plus V dawa P. It makes equation number D. We know the differential equation dz is equals to m dawa x plus n dawa y. Similarly, dawa m upon dawa y having x constant is equals to dawa n upon dawa x having y constant. We have observed from equation D, then m is equals to t and n is equals to v. Dawa T upon dawa V having S constant is equals to dawa V upon dawa S having pressure constant. Here we have finally derived Maxwell's second relation. Thank you so much guys. Please comment below for any questions and queries.